So welcome to class team. Today we will discuss about site comprehensions. This is one of the topic which is not covered in the last class. Then we'll have a discussion on performance, enhanceability, AI/ML use cases, and top 5 interview questions frequently asked in AI/ML interviews. So before moving to the topics, you need to complete this quiz again today. It have 10 questions and each question is having 4 options. MCQ type. Spend your 5 minutes on this quiz. The link of this quiz is available in comment. Now, if we talk about the comprehensions, I would like to recall some agenda related to comprehension. So instead of directly jumping to set comprehensions, we can discuss about the list and dictionary. So if you have clear idea of list comprehensions, then you will be easily able to map the same uh, concept here. So how exactly list comprehensions works? So comprehensions comes when you have a small statement, like you are applying a loop and then there is only one line you are writing. So let's suppose you need to find out even odd, right? Or let's say even numbers. So how you will write the logic for that? So let's suppose we have a list 1 L1 and there are couple of elements available 1, 2, 3, 4, 5, 6, and I want to find the even numbers from this list. So what I will do is I'll have a result variable and this result variable will be a blank list. I'll store here. So if we go ahead with the simpler approach, we will apply a loop here for I in L1. Then we can write the condition. How? If I modulus of 2 equal to 0, then only we'll be able to get the even numbers. So whatever even number we'll get here, we will append to result. So we can say result dot append, and what we are appending here, I. So if we print result, then we will get only even numbers from L1. So this is the simplest approach we are doing. The same problem we can solve with comprehensions. So let's run this program first and then we'll see what exactly comprehensions. This is a simple program which we have written using normal way. Now if we convert it into comprehensions, how you gonna write it? So what you need to do is you need to create a list where you are appending the result. So like this, similar like this. So I can write this entire thing in one line. So if I say result equal to a list here and then the variable I which I am appending into it. So this will be your variable. Then apply your loop here. Write the same loop for I in L1, for I in L1, and then your condition. The condition is if I modulus of 2 equal to 0. So how exactly it works? First, it will execute this loop for I in L1. Then it check this condition. If your I modulus 2 equal to 0, if this condition is true, then only it will add I here. So in case of 1, let's say you are iterating over L1 for I in L1. So first time I become 1 and it will check this condition 1 modulus 2 equal to 0, condition is false. So if your condition is false, then it will not append here. That is the way how it works. So you no need to externally mention the append. Okay. If your condition is true, let's say next time I is 2 and this condition become true, then it will consider this candidate I is 2. So it will add 2 here, comma. Then it will check for 3. So for 3, this condition is again false. So it will not append here. It will not give value to this. Then 4. For 4 again condition is true. So it will add 4 here. Then for 5 condition is false. It will not add again. For 6 it will do. So something like this. So same thing I'm just writing in one line. That is called comprehensions. So let's suppose if I do here result equals to I, same thing, I for in I L1, for I in L1, if I modulus 2 equal to 0, then we see result. So when to apply this comprehensions? When you have a single statement or a single condition within the loop. Let's suppose I have another condition, or I want to say, okay, in instead of this, if you have else condition, then you store in some other list, maybe R2, maybe even we call it odd. So odd list this. So what I'll do now, odd list dot append. If I go ahead with this logic, then this is not eligible. You cannot do for this because we are creating two lists here. So now let's suppose you are getting odd list and even list both here, but for this you are getting only even list. So if you want to fit in this into comprehensions, then you need to create again one more comprehension for this. But the problem here is same thing you are doing in one for loop where you are identifying the I is odd or even. Let me just make it even for better uh, understanding. Even list. And just replace it. Okay. Now that makes sense. All right. So let's focus on this first, this solution. So what I'm trying to do here is I have two lists and based on this condition, I'm appending to even list or odd list. Now both operations we are able to do it in a single loop. If you have this kind of requirement, then you need to do it in two list. Like this is one comprehension and this is another comprehension where you have a different condition. So my suggestion is if you have two or more than two logics to perform or maybe conditions, then you opt for the first approach. You go ahead with this. If you have single, let's suppose if you are trying to filter something on your list or with based on your single condition, maybe you have a data frame in machine learning and you want to do a cleanup based on certain condition, right? I want to do the cleanup of comma, or I want to replace something, or maybe I want to format my string uh, available in list, all the data points. So those things you can do with comprehensions. But when it comes to the op operations where you are doing more two or more than two, then go ahead with this. So this is how list comprehensions works. Same thing I'll map into set. So now same goes with set. So let's say instead of list, I have set. The difference in list and set is it can have duplicate, it will not have duplicates. So let's suppose S1, I have a sequence here. Maybe again we can take the same example with set 1, 2, 3, 4, 5, 6, then curly braces. So now if we want to create a comprehension here with set, then this will also done in this way. Result equal to use curly braces instead of square bracket, you need to use curly braces. Then syntax will remain same. So what I will do, I in, sorry, I for I in S1. Now I'm iterating through set. Then my condition is if I modulus of 2 equal to 0, and then close your color braces. So instead of using list, we are using set here because set is mutable and we can add or append to it. So if I do the same problem with set, it will look like this. So S1 equal to 1, 2, 3, 4, 5, 6. Then let's say result or even set, I'll say even set equal to like this. I for I in S1, if I modulus 2 equal to 0, then I'll print even set. So again, output will be same. So like we are doing a list comprehension, same way we can do set comprehensions and write a question for you. You need to explore what is dictionary comprehensions because dictionary is also mutable. Okay, so now let's discuss this problem, which is very frequently asked question in interview. So remove duplicates from a list while preserving order. So let's suppose you have a list here and then 1, 2, 3, 2, 4, 5, 1, 6. So preserving order in the sense whatever order the list is, we should have the final list also in same order. So if you see, if I run this answer here, 1, 2, 3, 4, 5, 6, order is preserved. So, and we have removed the duplicates. 2 is duplicate here, so 2 is only once. And again, we have 1 again, duplicate value, this is also removed. So if we go with traditional methodology to solve this problem, so what we are doing here is we are iterating through each element in L1. This is very must because we have to remove the duplicates, right? So we have to visit each element one by one. So this loop is okay. Now what we are trying to do here is if I not in unique list. So we created a list, unique list, and where we are checking for each element. If not in unique list, then only append, otherwise don't append. And that is how we are getting unique list. So now let's understand this uh, in detail so that you will have fair idea to solve this problem. And then we will use set for optimal solution. I'll just copy it. So now let's understand again. So what I did here is one unique list I created. This unique list is a bucket. So one bucket where we will keep all unique items. Now we are doing iteration for each element in L1. So let's visit first. First time I will become 1. Then we are checking if 1 not in unique list, which is blank right now. So there is no item at all. If not in, then append 1 here. So for first loop, for first iteration, your unique list will become 1. Then again, loop will go to item number second, which is 2. Again, it will check 2 not in unique list. So in unique list, we have only 1. So this is eligible again. It will append 2 to unique list. Then we are moving to next item is 3. 3 not in unique list. Obviously, it's not there. So we will be appending it. Then next item is 2. Then again it will check 2 not in unique list. 2 is already available. So we are, because condition is false, so this statement will not execute. Right? This will not execute means we are not appending. Then next item is 4. 4 not in unique list. So 4 is not unique in list. 1, 2, 3, 4. Then again 5. So 5 is also not there. Then it will append here. 1, 2, 3, 4, 5. Then again for 1. So it will check, okay, 1 is there. So condition is false. It will not append. Then it will check for 6. 6 is not there. Then it will append 6. So basically, this is the very basic logic. And if we implement our solution in this way, then we are getting the response or the results, the expected results. But the problem here is there is a huge time complexity gap. So now let's understand what exactly time complexity is and how we calculate it. So let's say for this loop, we calculate the time complexity in terms of n. So we say, okay, there are orders like best case, worst case, and average case. So if you write any solution in any program, so there could be three possibility. Best case is where our solution is performing the very minimal time you are getting the results. Then average case. So let's suppose I'll give one example for best case is you have a list 10, 20, 30, 40, 50. Now I want to search 10, which is your first. So when you start your iteration, you got the first time. The best case is the time complexity of your solution is O of 1 because first time you got and your loop is over. Okay, 10 I got first time, done. I no need to iterate again. Right. The average case for this is 1, 2, 3, 4, 5, the total length of list. Then I'll go till mid. Let's say I want to search for 30. So how many iteration I need? 1, 2, 3 iteration. So total 3 iteration I required. So I can say O of 3 basically um, 3 times, right? 3 times we are doing. So this is called average case where we are iterating through the half or mid of the loop and then you are exiting from there. Then that is the average case. Now, what is the worst case? If I find 60, which is not available, or if I am find 50, which is at the end. So I need to go through each of the element across the list till the end. And then I'm saying, okay, the element not found for 60. For 50, I got at the end. So means we are iterating each element one by one until your list or data frame, or if I talk about the database side, until your table is not finished. Right? You are scanning through, you are searching through that. So this is called linear search also, right? In linear search also what we do, we search for each element one by one till the end of your data set. So if you are iterating through the entire list, then we consider your worst time complexity is O of n. Why? Because let's suppose you have n elements in the list, then it will iterate through n number of time. So whenever we calculate the time complexity, we consider the worst case. This is this is the performance of my algorithm. So if I talk about the linear search, the time complexity for linear search is O of n because I need to visit each element once, at least once, to check whether this is available or not. That is called linear search. We will talk about binary search also later, but this is how the time complexity gets calculated. So in this solution, what we are doing is we are iterating through the L1. So L1 and we are visiting each element one by one. So considering this scenario, this will be O of n. Now, for each element, we are using in operator here. So in the last class also, even in list also, we have discussed it. If we are using in operator for list, then your time complexity will become O of n again, right? Because we are iterating through this list, unique list. So now there is a question, like a lot of people gets confused. So there are two ways to understand it. Let's suppose we consider the total element available in L1 is n and total element available in unique list is m. So now what we are trying is for each element we are traveling m time, not n, right? M time. So we are traveling m time. M is the length of unique list because of n operator. So it looks like, let's say for first time you are iterating m time, for second time again m time, third time again m time, then for n elements m time. So it looks like your time complexity goes to n into m, right? So there will be a lot of people who will say, okay, the time complexity will be n into m. But the truth is, let's suppose there is no duplicate available in your input. Then the length of L1 and length of unique list will become same. So that is why we consider instead of n, we consider n. That can be the last case. So then this m will become n. So we can say n into n. So the time complexity of this solution will be n square. This is the fundamentals while we calculate the time complexity. So if you are taking a different variable for other list, then make sure that you are not meeting to that condition where the list, both lists can have same length. If both lists can have same length, then consider the same variable. So now question come, can we further reduce the time complexity or space complexity? So I'll discuss space complexity in coming class, but let's focus on time complexity. So is there any way where we can reduce the time complexity from n square to maybe of n or whatever, but lesser than n square? Just think about it. So this kind of questions in an interview they will ask, and there will be a trade-off between your solution and one problem can have multiple solutions as well. So now we can further reduce the time complexity here using SAT. So how we can do that? Let's do that. Reducing using SAT. So let's suppose if I convert the entire list, this list, and if I say like this S1 equal to set of L1, and if I print S1, then it will look like, okay, yeah, we are getting the order, but this is not the reality. So this will give you an unordered the order of this. Maybe if I change the input 6, 7, 7, 8, 2, 3, 4, 1 like this. So this doesn't give the guarantee for your order. So this is not the correct solution. But what we can do is we can introduce set here. So let's say I'll have a set S1 equal to a blank set, and then we'll have a result variable where we will store the order, or or we can say the number of elements in a same order. So I'll iterate through the list for I in L1, and this is the way where I'm checking if I not in S1. So instead of using the same list for checking the membership, I'm checking in set. So if it is not available in set, then I'm adding into set and appending to result also. So if I run this program, see the output, both outputs are same. Now let's talk about the time complexity of this. All right, so we'll explore this solution. So what we are trying to do here is we are saying we are creating a set, a blank set. That's great. And we are creating a list also. Now we are starting I in L1. So your L1 is 1, 2, 3, 4, 5, 2, 6, 7. What are the numbers are? Now we are iterating one by one. So definitely for this, the time complexity will be O of on, O of n. Then we are checking if I not in S1. So this is the difference which makes a lot of difference in your solution. So in last class, we have discussed the membership in SAT. If we are applying an in operator in SAT, then it give you O of 1, not in O of n. This is the only difference. Now what we are trying to do here is we are adding into S1. So let's say for I, the first element is 1. So we are adding 1 in SAT and we are adding into list also. Then second time when I'm checking this, I'm saying, okay, I is 2, 2 not in S1. So I'm checking here. So 2 is not in this and appending to this. So this is my reference set where I'm checking a membership. If member is there, then only then I'll not add here. Okay, so instead of checking in here, I'm checking into set. That is the difference. And this makes a huge difference in your time complexity. So if you see now, for each element, the time complexity becomes O of 1. So for n elements, the time complexity will become O of n. Straightforward, we are able to reduce it from O of n square to O of n using this approach. Just instead of checking the membership in the list, we are checking in SAT. And this is the thing which you need to take care. So whenever the element is not available, you should add into SAT also. I agree. This will create another memory space. But here is the trade-off. Let's suppose if you need your execution faster versus your memory, you can do the trade-off. So you can say, okay, memory is not my concern. So whatever memory you need, you take it. But my concern is your solution should be faster. Then go ahead with this. If they are saying no, memory is the concern, we should use optimal memory and the performance or the time complexity doesn't matter. Then you can go ahead with the first solution or using another solution where you can use the same list instead of creating another list. So the number of variables or number of data types you create into memory, that will consume the space. So when it comes to the memory complexity, you always consider not to create more variables. If you use same variables, then it will be saving a lot of space. That is like kind of one of the best practice. So this is the way you can solve this problem and in O of n complexity. Memory complexity, I will talk more in detail in coming lectures. We will have more questions to solve. Now let's discuss these common patterns. When to use what? So you have list now and set also. So these are the scenarios, couple of scenarios which are covered, and these are the best practices you should follow. So let's say if you need a unique element, then set is preferred, as we have seen that. Uh, List is not preferred. Fast membership test. Let's suppose if you need to use in operator, then go ahead with set O of 1. This is not preferred. You can do in both way, but the preferred one, best approaches. Let's say when order matters. So any scenario where you need to consider the order and it matters for you, then don't use that. go ahead with list. You need an indexing because SAT doesn't support indexing. You should use list. Duplicate allowed. So SAT may there's no duplicate allowed. So don't use SAT, use list. If it comes to memory efficiency, then use list. So whenever the trade-off between your memory versus time complexity. So when it comes to time complexity, go ahead with SAT. And when it comes to memory complexity, then go ahead with list. So there is a trade-off in both. In fact, in coming sessions, we will solve one problem every day, maybe in 10-20 minutes first, and then we will go ahead with the real concept of Python. So that will give more learning towards how you solve the problem in interviews. So now this is one of the topmost interview question asked in interview for AIML engineering. There are two data sets. One is L1 A B C D E and L2 D E F G H. So now what we need elements which are in L1 and L2 but not in both. Means we need to remove the common elements from L1 and L2. So for this in SAT we have one concept called symmetric difference. So how you can do that? So first of all you convert these two lists into sets. So let's say S1 equal to set of L1, then S2 equal to set of L2, then this is the way data equals S1 dot symmetric difference. So this is already available method in SAT where it creates the symmetric difference. Then once you print data, the output is here A, B, C, F, G, H. You know, like the order is different, definitely. So again, whenever interviewer ask this question, you should have couple of questions before starting your solution. First question is, do we need to preserve the order? So if he says no, order doesn't matter for me, then this is the solution. If he says, yeah, order matters, then you need to think another solution where you can use the symmetric difference, but in other ways. So this is a question for you also. Just think about it. If I want to preserve the order, let's suppose A, B, C, F, G, H. That will be the order of the final output if we preserve the order. If order is not matter, then you can go ahead with the solution. So this is one of the available method. And if you want to use operator, you can use that. So let's say data 1 equal to S1 not operator. So we are using this operator, what we call cap something. So then if you print data 1, then you can see again the output is same, but again the order you have to preserve in different way. So like this you can identify all the elements which are available in both the list but not on the common elements. Okay, now let me iterate through the time complexity. So let's suppose you have n element in L1. So here it says O of n, and if we say m element in L2, then time complexity will be O of m because we are converting from list to SAT. And for symmetric difference, this is a linear because we are using a hash table here. So it gives you O of 1 lookup. So mostly it goes to near to O of 1 for the symmetric difference because of hash table. So it uses hash table. Then if you want to change your data into list, let's suppose if you say list of data like this, so again it will take some complexity like O of n plus 1 again or so the final will be This will be considered here O of n plus m. And if you say both lists are same, then it will be n plus n, right? But to differentiate in both, where is that code? Here it is. The output is in list now. So to differentiate in L1 and L2, because there is a rare chance where we will have both lists are same in this case. So that is why we have taken an element in L1, m element in L2, and then accordingly we are saying n plus m. So the interview tip is for set operation when you are talking about. So set operations like symmetric difference are linear because they rely on has table. That is why it giving average O of n lookup. So we are leading to overall n plus m complexity. That is the one of the reason. And in membership, like when we are using in operator in SAT, we have O of 1. So now here is the question for you to solve. The question is given a string as create a set containing all unique orders or ordered pairs of consecutive characters. For example, if you have let's say one sec. Let's say your string is A B A B C. This is a string. Now we need to create the pairs. So the pair will be consecutive pairs. A comma B. This is your first pair because we are considering these two. Then you have again next pair is B A. B comma A. Then third A B. Right. Then again B C like that. B comma C. So if you see here, we have total 4 pairs. Now, because we need unique ordered pair, so what we can do is we can avoid this one because this is duplicate. So A comma B, B comma A, and B comma C. So these are the 3 pairs we should get in our output. So this is the question from lead code also I have taken it. So you can start lead code and try to solve it. In next lecture, we will discuss the solution of it. We will build the optimal solution, and then we will discuss about functions